Good morning. Welcome to Code for Fun, program for secondary school. I'm Esther, and I will be your trainer for today. I'll be sharing with you on the topic on computational thinking. Let's start. So, what is computational thinking? Let me explain to you. Computational thinking is not thinking like computers. It's a problem-solving technique. Problem-solving technique that helps you to solve problems. So, what are some activities that you use for computational thinking? Some examples that you may already using computational thinking. Maybe for this morning, when you woke up, just feel like just try to think, what is the faster route I can go to school? You already start the planning, right? Yeah, that's part of computational thinking. So computational thinking consists of 4 steps. Let me explain to you one by one. Decomposition, all right, pattern recognition, abstraction, followed by algorithmic thinking. Decomposition is breaking down complex problems into more familiar or manageable subproblems. So when we talk about pattern recognition, we're reviewing how the previous solution that can help to solve similar problems. Okay, abstraction. Abstraction, which is identifying and focusing on relevant details that can affect the solutions. And lastly, algorithmic thinking, which is we are using a sequence of steps to solve problems. Don't worry, I will explain to you more I will explain to you more later. Let's move on. Decomposition. So what is decomposition? Okay, so decomposition, we need to break down the problems into smaller parts. Example. First example, would you eat a whole burger in one mouthful like Scooby-Doo? Or take it in small mouthful? Or how you memorize these strings of numbers? You will just read it in a row, we just break it up. Let's say, like me, you can read it like me. 5, 4, 3, 2, 1, 8, 7, 6, 5, 4, 5, 4, 6. So, all the above are done by breaking the problem into smaller parts to solve them bit by bit. Yeah. The Scooby-Doo. Next, we're talking about pattern recognition. Pattern recognition, which is we finding similarities among objects or stations. So look at these 6 items. What do these items have in common? Students, can I have your answer? Yeah. So first, these pictures, they have at least 2 common similarities. First, they all are round. They have round shapes, right? Second, that's right. All of them can spin. Good. That looks at the second one. What do these items have in common? Okay, so when you look at this one compared to the previous one, they have different sizes and different shapes, right? But there is a common similarity between. What is that about? Yeah, that's right. All of them starts with the letter B. We have ball here, we have boat here, we have ball here, we have bone, boat, right? Yeah, all of them start with the letter of B. So finding similarities among objects, and sometimes it may not be as obvious, we call it pattern recognition. Okay, next, abstraction. Abstraction, which is we pulling out specific differences to make one solution work for multiple problems. For example, look at these pictures here. All animals, right? Focusing only on the necessary details and taking out parts that do not matter when we talk about these animals, we can see which animal can fly. So will you look at that skin color? No, right? Even they have different colors and numbers of legs and presence of wings or presence of tail. Right? When you look at the we need to find out which animal can find, right? We don't look at the skin colors, we don't look at how many legs they have or tails, as long as they have wings, right? Wings can make them fly. Okay, yeah. Next one, algorithmic thinking. Using a sequence of steps to solve problems, we call it algorithmics. It's a very, very good example here when we do baking or cooking, where we follow the recipes. We follow the step, right, from the recipes, step 1, step 2, step 3. And afterwards, when we follow all the steps, then we can create the perfect final cake and dish and present on the table. So, the essence of computational thinking involves breaking down complex problems into smaller parts, called it composition, and so that we can have more familiar and manageable sub-problems and reviewing how the past solutions transfer to a similar problems. We solve problems, right? So we call it pattern recognition. And also we identifying and focusing on relevant details that can affect the solution, call it extraction, and using a sequence of steps, acronyms to solve problems. Finally, from here, we'll be able to determine if a computer can help us more efficiently solve all the problems. Thank you. Have any questions? You can text me.